be sent to. All that we discussed so far is about public network on Ethereum. Let us look at other kind of networks in Ethereum, like private network. An Ethereum network is a private network if its nodes are not connected to a public network, that is mainnet or a testnet. In this context, private only means reserved or isolated rather than protected or secure. To develop an Ethereum application, you will want to run it on a private network to see how it works before deploying it. Similar to how you create a local server on your computer for web development, you can create a local blockchain instance to test your dApp. This allows for much faster iteration than a public testnet. Sometimes it is also called a development network. Consortium network. The consensus process is controlled by a predefined set of nodes that are trusted. For example, a private network of known academic institutions that each govern a single node, and blocks are validated by a threshold of signatories within the network. If a public Ethereum network is like the public internet, you can think of a consortium network as a private intranet. All of the above networks are in Ethereum 1.0. That brings us to the question, is there any other version of Ethereum out there? And the answer is yes. The newer version is Ethereum 2.0. It is still in early stages and may take another 2 to 3 years to replace Ethereum 1.0. The open source development is currently underway in Ethereum 2.0 or ETH2 as it is sometimes called. The Ethereum 2.0 upgrade, also known as Serenity, is designed to be launched in 3 phases. Phase 0 will create the beacon chain, a proof of stake blockchain. Phase 1 will create shard chains and connect them to the beacon chain. And phase 2 will implement state execution in the shard chains. The current Ethereum 1.0 chain is expected to become one of the shards of Ethereum 2.0. Ethereum 2.0 has 5 main design goals. Minimize complexity by simplifying the Ethereum blockchain even at the cost of efficiency. Improve uptime and keep the Ethereum network live during major network splits. Ensure longevity by building Ethereum 2.0 with elements which are either quantum secure or can be easily swapped out for quantum secure replacements when available. Increase security by using design techniques which allow a large number of validators to secure the network by staking their ETH holdings. Reduce barriers to entry, making it possible for a typical laptop to process or validate shards. ETH2 makes extensive use of BLS signatures for cryptographically assuring that the particular ETH2 validator has actually verified a particular transaction. Some technologies have made statements like Ethereum 2.0 includes major changes that could end Bitcoin's blockchain dominance. So, what are those few changes that will make Ethereum 2.0 far more effective than its predecessor Ethereum 1.0 and also over Bitcoin? The first of the major change is introduction of proof of stake consensus mechanism. The early blockchain implementations like Bitcoin and Ethereum 1.0 suffered from performance issues as they relied on a processing power intensive process known as proof of work to validate and record transactions. The problem with proof of work is that it's terribly inefficient, and that is by design. To begin solving that problem, Ethereum 2.0 is going to transition its blockchain to a more efficient proof of stake system. In such a system, the node that records each transaction is chosen by an algorithm, with chances of selection increasing with the amount of the currency the node's owner holds. That makes it possible to dramatically decrease the complexity of the cryptographic work, leading to massive throughput gains for the whole network. As each node must take its own currency to participate, it would remain prohibitively expensive for anyone to attack the network. The second change is introducing sharding. Ethereum 2.0 will also introduce a processing technique known as sharding. In the current blockchain version, all data that is added to the chain has to undergo verification by all participating nodes. That means that the processing speed of the entire system is limited by the speed of its slowest participant. It creates a bottleneck that increases transaction cost and decreases throughput. By adding sharding, Ethereum 2.0 can accomplish the increase in efficiency of its resources by breaking data verification tasks up among set of nodes, and each will be responsible for verifying just the data it has received. That allows the whole blockchain to make use of parallel processing, which could increase overall capacity several times over. The third change is replacing EVM with EWASM. One of the features that have made Ethereum such a viable platform is its implementation of the Ethereum virtual machine. The EVM is an execution environment that runs on all network nodes that facilitates the use of smart contracts. We already know that. It is these smart contracts that make Ethereum's blockchain a global computational device rather than a mere financial system. Smart contracts on EVM can run games, execute complex financial transactions, or even operate social networks. Although EVM is widely used, it remains something of an enigma even for people with high degree of programming skill. To address this, Ethereum 2.0 will begin the use of WebAssembly language in a system they are calling EWASM. That would make it possible to execute Ethereum app code right in the today's web browsers, which is a massive improvement over the EVM. Also, it will allow programmers to choose from several languages like Rust, C, and C++ to write code to run on the blockchain. This change, introducing EWASM, will increase the number of potential programmers for the ecosystem because it will open the doors to users with no need to learn a native Ethereum-only language.